Introduction to intervals. We'll begin with intervals and interval notation. There are various ways to write an infinite set of numbers on the real number line. Here are some examples, and in all cases, the value of the variable a is less than the value of the variable b. For a closed interval, we have square brackets with a comma b and square brackets on the other side. In inequality form, an example is that -2 is less than or equal to x, which is less than or equal to 4. And in interval form, we say that x is contained in, that's what this little curved E means. It means is contained in the closed interval from -2 to 4, where both -2 and +4 are included. And notice on the number line representing it, we have closed circles at both of our endpoints, -2 and +4. For an open interval, we use regular parentheses, a comma b. So here we have an open circle on -3 and an open circle on 5. In inequality form, this represents -3 is less than x, which is less than 5. And in interval form, x is contained in the set of numbers from -3 to 5, not including both endpoints. You can also have what's known as a half-open interval, where you have a closed bracket on the lower bound a and an open parenthesis on the upper bound b. So we have at -5 in our example, we have the closed circle, and at +1 we have an open circle, and it is shaded in between. Therefore, the inequality for the numbers represented on this number line are -5 is less than x, less than or equal to x, which is less than 1. And in interval form, this is written as x is contained in the interval from -5 to 1, where -5 is included. Here's an example for an open interval, which means using parentheses from a to b, where a is less than b. Write the set of real numbers between -3 and +5 as an open interval in 3 ways. The graph is the first way to represent the real numbers between -3 and +5 exclusive, meaning we are not including the endpoints. So that would be an open circle on -3 and an open circle on +5, and then the shaded area or the included area is between these two values. Written as an inequality, it would be -3 is less than x, which is less than 5. And now we have to come up with the interval notation. So remember, with interval notation, it begins with x, that curvy looking E, which means is contained in. And then when it's an open interval, we use regular parentheses, and we're going from -3 to +5. And here's the solution for the interval notation, and it does match the solution that we wrote on the last slide, which is that x is contained in the open interval with parentheses from -3 to +5. Now let's try this example, example B, which is going over the closed interval from a to b, where it has square brackets on both sides. The directions are to write the set of real numbers between -4 and +3 as a closed interval in 3 ways. So the first way is the graph of the real numbers between -4 and +3 that is inclusive, meaning that it includes both endpoints. So because it includes both endpoints, we use filled in circles on both sides at -4 and +3, and then we shade or draw a line between these two numbers. So that's the first way of representing this closed interval. In inequality notation, the second way to represent it, it's -4 is less than or equal to x, which is less than or equal to 3. Now let's write it in interval notation. Remember, that starts with x, that curvy looking E, which means is contained in, and then because we have a closed interval and we are including both endpoints, or both endpoints are inclusive, we use those square brackets, and we begin at -4 and include it, and we end at +3 and include it. And here we can see the solution that shows interval notation, and this does match the solution that we found. x is contained in the closed interval, meaning the square brackets on both sides, from -4 to +3. And because we have square brackets, that means that they include both endpoints, or both endpoints are inclusive in the set. Here is an example of a half-open interval from A to B, where A is not inclusive, but B is inclusive. So write the set of real numbers between -2 and 5 as a half-open interval in 3 ways. In this graph of real numbers between -2 and 5, inclusive of 5 but not -2, it would appear as shown. The open circle on -2, because that is not being included or is not inclusive in the set, all the way up to +5, and that is a closed circle because the set is including our value of 5. If we write it in the second method or way as an inequality, it would be -2 is less than x, which is less than or equal to 5. Now, how would we write this as an interval? Well, since -2 is not being included, we still begin with x is contained in with that rounded e, and then the -2, since it's not included, is an open parenthesis, and we're going up to 5, but then 5 is included, so we're using the inclusive bracket. And here's the solution for the interval notation that we wrote, and it reads as x is contained in the set of real numbers between -2 and +5 that's inclusive of 5 but not -2. Here's another example, this time with infinity. Write the set of real numbers less than or equal to 3. Well, as a graph, all real numbers less than or equal to 3 is going to have a closed circle on that value of 3, and then we're going to shade or draw our arrow to all points to the left of it, and we include the arrow at the very end to show that it continues in that direction. When we have it as an inequality, it can be written as a compound inequality in this way. From -infinity, which is less than x, which is less than or equal to 3. You could also just write it as a single inequality without it being compound. And if you were to do that, it would be just written as x is less than or equal to 3. If we write it as an interval, we have that x is contained in, remember x and then that rounded e, and now -infinity is not an exact value, so we always use a open parenthesis, so we have -infinity to +3, and then because that's included or is equal to, we close the interval with a square bracket. And here we have the solution showing the interval notation, and it does match the solution that we found, which is that x is contained in open parenthesis, -infinity to +3 with a closed bracket because 3 is being included. Here's another example with interval notation and infinity. We are going to write the set of real numbers greater than 5. So when we graph this, we are going to graph the real numbers greater than 5. So we have an open circle at 5, and we are shading or pointing our arrow to the right because it's everything greater than our 5 value. This time with inequality notation, it is given to us as being x is greater than 5. Now, it can also be written as a compound inequality if you would like. And since we have x is greater than 5, we can switch this around and say that 5 is less than x. And we know that both of these are true because the Pac-Man or alligator is eating x in both cases. So these are equivalent, but then it's less than infinity. And this will help us with the interval notation because we're going to begin with 5 as our lower bound, and it's not being included. So we just do the regular parenthesis, and then it goes up to infinity. And remember, we also have to include the x is contained in symbol at the beginning. And here's the solution to this example, and it does end up being the same interval that we found, and that's that x is contained in the open interval from 5 to infinity, and we have parentheses on both sides.